podcast.
Mom, did you want to take your pillow? Oh my God, my mom is telling my grandma.
That's okay. It's important. All right. So, no, oh, my daughter is playing with deodorant. Hold on, I'm going to grab that from her. Yep, we're deodorizing the Kleenex. I will be right back, and then we will get started. I'm going to advance the slide to slide 2. This is what I'll be right back. No, 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 no. No, Lizzie, come on. Did you put deodorant? I don't even know what to do with you. Oh my goodness. Oh. Seriously, oh my gosh. She put deodorant on her feet. Now, her feet smell like a dude. I mean, it makes sense. Feet get stinky, but come on. Really? Oh, that girl. Like, she gets into it. Is everybody else alive today? Oh, yeah, it's Old Spice deodorant. It's Swagger. Yeah, it's good stuff. Good stuff. Oh, you have a bad connection. Shoot. Is it Casey? Stella, can you guys hear me okay? Jana? Okay. Okay, cool. Okay, good, good, good. I think that's what he's doing. So, all right, we will get started. Yeah, we're going to talk about reflections, translations, and rotations. Cranky, no, that's bad. Throw it in the water. No, don't do that. Okay, so today it's a lot of translations, reflections, lines of symmetry, and I actually went through the Moodle pages, and the Moodle pages are really, really, really helpful for these lessons. They are super helpful. So, is Tyler back? Tyler's back. Beth is here. Hi, Beth. Okay. So, from last week, you guys did transformations, and I actually, I'm going to go through the Moodle page just to show you and kind of go over it a little bit.
Hey, hi, watch this.
Oh my gosh, you smell like a dude, Lizzie.
Watch this.
She smells like a dude. Whoa, okay, go sit down now. Okay, so this is the yeah, she does. Bad words, a dude, not like a, like a guy. She smells like a guy. That's what I meant. Okay, so transformations talk about movement in geometry and a plane. So it's important. This is the Moodle page. This is right on the week 14. If you click on that and then click on the, oh, here it is. Okay, the video's there. It's just taking a while to load, but there's transformations right on the Moodle page there. And it's really helpful. It's very simple. It goes through all of these terms, talks about a transformation is a change in the position, shape, or size of a figure, a geometric figure. Rigid transformations are where the sizes stay the same, so they don't shrink or grow or anything. The pre-image is the original figure, and the image is the original finger. This is, I said finger, I meant figure, not finger, figure. But right here, I'm waiting for, yep, I was waiting for Frankie to comment on that. So this is pretty key to what we're going to be doing and stuff today. With the image, you guys should know we'll have a pre-image, and it'll be labeled like triangle ABC. and the image would be labeled as like A prime, B prime, C prime, whenever you move the figure. You guys can see my writing, right? Finger. Yes, I am. I just said the wrong word. Okay. Today we're going to talk about translations, which is a slide of a figure. I like that word. No, don't put your feet on here. Yeah, they smell. Wow. They smell very good, actually. Very swagger-ish. Okay. Yep. Say hi, friends. Okay, go sit. Go sit. You hurt your toe? I'm so sorry. And then we have a reflection, which we'll talk about today too, which is a flip of a figure. And we're mostly doing this on the coordinate plane. So yeah, so this is a really helpful Moodle page. It kind of takes you through. No, don't do, stop that. What are you, oh my God, sorry guys. Lizzie, stop, go sit down. That is what she's doing. She's like, why does it smell? I'm like, I don't know. Something interesting here is a lot of this, right? A lot of what we're doing has applications with like architecture and art. It's really neat stuff. If we look at artwork and buildings, you'll see a bunch of translations, rotations, reflections, and dilations. And they do this using this mathematical technique. So it's really cool. Astronomers study things. No texting. You gotta listen. Gotta listen. Listen to me. She's texting right in front of my face. That's so nice there. And then there's some examples there, but that's from last week. So this week, we're going to most specifically talk about translations. Oh, that's okay. No problem. Granky says welcome. Okay. So a translation, as Frankie beats me up, no, is a slide of an object from one position to another. It does not change the size, shape, or the orientation of an object. So it's just a slide. Okay, whose hair is whack? Whose hair? Oh. Okay. I like your hair. The flappiness of it, it's good. Okay, so here's what I want you guys to do. Translation is a slide of an object. It does not change the size of an object or the orientation or the shape. So I want you guys to pick a color and circle all the pictures that are translations. So I want you guys to circle all of the translations in this figure here, in these diagrams. You should be able to. Yep, okay, good. Circle all of the translations. And I'm going to say it again. Remember, a translation does not change the size, shape, or the orientation of an object. It's just a slide. That's it. I like what I'm seeing. Get all those circles on there. That's what my daughter says. She always like, there. Yep, that one's definitely not a translation because it's a size change. What about the lions or tigers, whatever that is? That one isn't really an orientation. That would be like a size change. It's a dilation. So it's when something gets bigger or smaller. So that one is not going to be a translation. Good. But yeah, you guys are right. All of the ones that you have picked are all slides of an object. Yeah, it just looks like it took an object and moved it from one place to another. Good. Very good. Orientation is like a flip. So Yeah, so it like a reflection, that would be a change in orientation, or a rotation, that would be an orientation change. But these, none of these are really rotated, they're just slid. It is curly, super curly. I don't know what you guys are talking about. Are you talking about music? Is that
Panic at the Disco.
Oh, I know that. I know who Panic at the Disco is. My niece is like obsessed with them. All right, so coordinate plane. Here's the key stuff that you guys have to have written down. When you move an object, excuse me, a certain way on the on the coordinate plane, it changes your coordinates, okay? So again, key slide, make sure you have this written down. This will help you with that homework. If you have a translation of something to the right, it increases your x coordinate, okay? So let's say we have a coordinate over here. This is at x is -2, y is 3. If we move it to the right, let's say we move it to 2, 3. Your x coordinate is increasing. You're actually adding. Yeah, you're right. That's good. And that's good to know. And that's key to have on there, that this is the positive area, this is the negative, because you're moving toward the positive, so your x value is increasing. If you go left, your x value decreases, but the y, there's no change. If you go up, your y value increases, down, x value decrease, or y value decreases. Just think about the coordinate plane. If you move to the left, you're moving toward the negatives. Hello. If you move to the right, you're moving toward the positives. If you're moving up, you're moving toward the positives. Down, you're moving toward the negatives. Okay? Anything with a chart like this today would be really helpful for those coordinate planes. So I would take a shot of that, write it down, whatever you do. And you don't even have to write the words. You could just write, like, if there's no change, if it increases, you could put plus, decreases minus, whatever. No adult beverages? No way. No way. I'm drinking a Monster, an orange one. Ooh, nummy. Product placement. Did you guys... Oh, not that. Like a screenshot. That's what I meant. Did you guys see in Game of Thrones there was like a coffee cup in one of the shots there? When Daenerys was... I don't know if you guys watch Game of Thrones.
That's not what it was.
It wasn't? Oh, hi, Allie. Oh, yeah. Not this season. Not this season. But you're right. You're right. It is. Yeah. I'm not a fan. They don't need that. I'm like, come on, put it away. Don't, gross. But the yeah. The action stuff is really cool. Like the battle with the White Walkers was awesome. All right. So, we're going to talk more specifically about the notations. These are the different ways that you guys will see a translations there. Hey, we'll keep that out of the discussion right now. Okay. Yeah, but that's cool that you went to prom too. Okay. So the translation, you can have... Oh, yeah, of course. Yes. Go ahead and write the increase, decrease, all that stuff. We don't have terribly long content today, so we actually will finish on time without an extra video. Yay! That's our goal. What a day. That's like the song, oh, what a night.
Oh my god, I literally just started singing that.
Did you really? Oh my gosh.
Oh, what a night.
I used to sing that all the time. Love that song. Late December back. Okay, I'll spare you. Sorry. Okay, do you have it, Casey? Okay. All right, so these are the different ways that a translation can be noted, okay? You might have a description where they actually spell out what happens. You go 3 units to the right and 2 units down. You might have a mapping where it tells you these are the original coordinates, and then to get the coordinates, you add 3 to the x and subtract 2 to the y. And remember, when you add 3 on the coordinate grid to the x, when you add, you're going toward the positive area there. Okay, adding 3. If you subtract 2 to the y, that means you're going down toward the negative area. Just think of that coordinate grid. Think of where it's positive and negative on the x and positive and negative on the y. That really helps you figure out where you're going. You also might have a letter, meaning your point. The 3 tells you to add 3 to the x, and the negative 2 tells you to subtract 2 from the y. So either way, however it's written, what remains the same is it's always going to be xy for your coordinate point, and they'll either spell it out, they'll either show you the operation, or they'll just do a little symbol that tells you what to add or subtract. And if I were you guys, I would write, you know, this part. I would write the 1, 2, 3. I would write the description, 3 units. I mean, you really don't have to write that one out. You could just write the word description because I think it's pretty self-explanatory. I would write the mapping. I would write a little note that says this means add 3 to your x. If you need to write it out, it does say that, you know, up to you. And this means subtract 2 from y. Or you could put a little note that means this goes right 3. This means down 2. And then this one is the same thing. I would put that symbol on there. I would say that this 3 means add 3 to x, subtract 2 from y. So there's a lot. Those are the 3 ways to note it. Remember, A is your original point. A prime, that's how you say it, A prime is your translated point. So that's the point after you do the movement. And when you are done, can we do the hand raise thing just to make sure you guys all have this? Who left? Just raise your hand when you're done making a note of whatever's on here. Oh, okay, got it. No problem. I didn't do it. I didn't kick you. Internet's a little spotty today. Yep, so just raise your hand when you're done writing that down. I know that's a lot of stuff, but it helps so you don't get confused. And remember, it's listed really nicely on the Moodle page. It really does kind of show you good examples of what to do. I think that's what I'm going to work on this summer is listing it out real nice. I think that's helpful. I'm doing school over summer, but I need something to do. I get too bored. I like tinkering on my computer. Yeah, it helps. I'm even sending my kids to summer school. They need it, otherwise it's too boring. But you'll probably be busy with horses.
Let's be honest. The real reason you're sending your kids to summer school is so you don't have to watch them.
Oh my gosh, yeah. Yup. You hit the nail on the head there. Because they're great. Speak of the devil, right? No, she's a good one. She's snuggling her kitty.
The kitty is awake and I'm sleeping. I'm just kidding.
The kitty's awake. Oh, she brought me a kitten. There's my kitten. We have to take our other cats to the vet today. I think my older male cat is on the way out, sadly, but he's pretty old.
Yeah, it's pretty old.
He's pretty old. Oh, I saw that on Facebook. How did she do? Nope. Oh, sorry. No.
I made it.
She what?
Did pretty good. We learned some sad stuff though.
Oh, I'm so sorry.
She apparently has a broken vertebrae in her back that healed wrong.
No, Lizzie, no. It healed wrong?
Yeah, so she will never be able to fully straighten her back.
Oh, man.
And she has a kneecap and one of her legs that is not in the correct spot.
Oh, baby Nala. Okay.
And her other leg, her leg was broken and healed twisted. So that leg will never be fully straight.
Oh, baby girl. Can she get like assistive stuff to help her, or would that not work properly just because of the...
I'm not sure. It's very possible a cart will not work, but we're going to try it.
Yeah. Oh, I'm so sorry to hear that. Was that before you guys got her that she was...
It was while she was in the womb. Her mom was hit by a car while pregnant, and Nala got the brunt of it.
Oh, but she's here.
Yeah. None of the other pups were affected.
Oh. You guys are the best for choosing her and giving her the best life she could have. I loved the picture you posted with her cute eyes. They're so gorgeous. The different colors. Oh, so cool. Okay. I think we all have it pretty much. Stella, are you good? Okay. Cool. So we're going to keep on cruising. I'll show you some examples. And then we'll go from there. So, okay, so in this example, you can kind of see we have an object that was moved from up here to down here. It's important to kind of know where you're at with that. Remember, the one without the primes is your pre-image, and the one with the primes is the image. So that's after the translation. So if we want to figure out what happened, we're just going to pick one point and kind of count what happens until you get to the next point. You don't have to go right or left first. You just have to have the correct numbers, basically. So to get from A to the other A, what do you guys think is the correct description? And again, we're just going from A to A here. And then B to B. The same translation would work. Elizabeth, go sit. I know. Thank you. Go sit. Beth, what do you think? No. Go sit. What do you think, Beth? Which translation description works the best? And I'm going to get lots of opinions here. I said, Beth, you need to raise your hand. But Dallas says number 1. Beth, you agree with him? Okay, number 1. What about you, innocent little baby? Innocent little baby, what do you think?
One second. My annotation tool's on. Okay, it's up 5 and 7 to the left.
Up 5 and 7 to the left. Remember, we're starting at this guy.
Oh, I thought we were starting at the other way.
Yes. It's common, right? Because you think the regular one without the primes is where you should end because that one's like unaltered. That's what I always think. But remember, with the primes, that's the second image, the after the translation. So it would be the reverse of what you said. So it'd be 1. Yeah. So we would go up down 5. So 1, 2, 3, 4, 5. So we got that part. And then right 7. 1, 2, 3, 4, 5, 6, 7. So it's definitely it. And it should work with B as well. So 1, 2, 3, 4, 5, 6, 7. Yep. 1, 2, 3, 4, 5. So it's definitely going to be number 1. Good. Common mistake is to do exactly what Casey did and think that this is your starting image and you should end with that. That's what I always think. That always gets me. Just try and train yourself that this is the starting one and this is your finish. Yeah, so that would be the description. If I wanted to list that as mapping, again, I'm just describing what happens to the X and to the Y. So here's my X and my Y. If I went 7 to the right, do you guys think that would be a +7 or a -7? What do you guys think? Plus, yeah. Allie, I agree with you. You guys agree with Allie? You think plus? Yep. Yeah, it would be a +7. And then what about the 5 down? Minus. Yeah, we would go -5. Very good. And then the symbol, we would just, I believe it's common to use that T for translation because if it's a R, they would say rotation. Sometimes I've seen it with the actual points, but there's 4 points. That doesn't make sense to me. But they'll say it's a translation of right 7, down 5. Oh, my bad.
Cutter because this is my toy fork.
Oh, sorry. I put her toy fork in the regular cupboard. How could I? Oh my goodness. You guys have that written? C. Allie says C. Si, senora. Okay. So what we want to do is, you can ignore this poll. That was from last year. I was doing some weird stuff. That was when we had Collaborate. It was a lot easier to give out polls. So it's easy to do it now, but I just didn't have time to type it all. Okay, so someone raise your hand, and who would be willing to, and you know what, let's do this. Let's list what the points are for D, C, I think that's a B down there, and E. So who can list D? Innocent little baby, can you write the It's only dreamer? Oh yeah. Yeah. Okay, innocent little baby says D is at 4, -4, definitely. Okay, who can tell me what C would be? Allie, what's C? And you could write it on there or type it in chat.
Oh, I was gonna say it.
Oh, you can say it. Go ahead. What's C?
C is x to y -6.
Perfect. And what about B? Who can give me B? Miriam? What do you think? And you can type it, write it, tell it, whatever you want to do. Oh, excuse me. B is at 3, -8. Yep. And what about E? And it's good to do this, guys, because we want to make sure that we're reading it correctly. Beth, what's E? Six, -7. Yep, definitely. Okay, so now, there's a few ways you can do this. You could either move each translation and just count it out. You could add the translation to the points, or you can, actually, I think that's it, just 2 ways. So I kind of want to do it where we just kind of add it on there. So what would we do to get D prime? It tells us that we're going to go 4 to the left, or take whatever x is and subtract 4. Where would that put our x at? Innocent little bit. Or Stella, yep, you're right. It is at 0. Perfect. Because 4 minus 4 gives you 0. And we can even check that. If we go 4 to the left or 4 in the negative direction of x, that's 1, 2, 3, 4. That's it. And then we got to go 5 up or add 5. Oh, that's totally fine. Totally fine. No big deal. So if we add 5 to that -4 for y, what would that be? What would that be? Miriam, what do you think? If we add 5 to where our y is, 1. Yeah, because -4 plus 5 gives you a +1. And we can even check that, because if we went left 4, then we're going to go up 5. 1, 2, 3, 4, 5. That does put us D prime at 0, 1. Good. So then what would C prime be? Who could tell us what C prime would be? If you could raise your hand, where would C prime be? Allie, what do you think? X would be -2. Okay, yep, I agree, because you're going 4, or 2, excuse me, minus 4. That puts you at -2, and we can check that. If we go 1, 2, 3, 4, definitely at -2. And what would Y be at, Allie? -1. Yep, because if we add 5, that does put you at -1. So from there we go up 5. 1, 2, 3, 4, 5. There is our C prime. And it threw me for a little bit because I was like, wait a minute, where? But we'll see it with the whole object. What about B prime? Who can tell us where B prime would be at?
And I kind of open the box page.
Okay.
I kind of open the shelves.
Okay, that's fine, but I'll help you paint as soon as I'm done here, Lizzie, okay? What do you guys think? Dallas, what do you think it would be? Yeah, you can open the shells, just not the paint. -1, -3, Dallas says. Let's check that. Thanks, Dallas. Yep, I think I agree with you there, my friend. Because if we take 3 and we subtract 4, that does give us -1. So we're going 4 to the left. 1, 2, 3, 4. We're at -1. And then, oh, that's my mother. Talk to you later. Okay, give me a second, Liz. And then we go 5 up. 1, 2, 3, 4, 5. Yep, that definitely puts us at -1, -3. Very good. That is our B prime. And then what about E prime? What would that be at? Miriam, what do you think? For E prime. 2, -2, says Miriam. Let's see. Oh, yep. If we subtract 4, that gives us 2. And then if we add 5, that gives us -2. Totally agree there. Very good. So we go right, or excuse me, left. Good job, Lizzie. We go left 4. 1, 2, 3, 4. Up 5. 1, 2, 3, 4, 5. So there is our lovely figure, and we can draw in our sides. Oh, I love you too, big girl. Oh, sorry. My hand is being accosted there. But yes, that is what we would do. Does anybody have any questions with that? Go sit down. Go sit. You want my phone? I'm like, take my phone. Go. Get out of here. Okay.
Hello.
Oh.
Hello.
Hi. Okay.
Hello.
Oh boy. All right. So. Okay. So. Oh, Lizzie, you're. Shoot. My mic just. Can you guys hear me? Hello? Can you still hear me? Hello? Oh, there it is. Okay. She turned my volume of my mic into my headset down. Messes me up. Okay. So what they're going to have you do is they'll have you do like a little bit of like double mapping and then saying what the new rule is. So we start with the point 1, 3. Translate the point using the mapping thing of subtract 2 from the x and add 4 to the y. What would j prime be? What do you guys think? Who can tell me what would j prime be if we have to subtract 2 from the x and add 4 to that y? Allie, what do you think it would be? -3, 7. Yeah, very good. Well, we would subtract 2 from the x, so 1 minus 2. I think you did -1 minus 2. 1 minus 2.
I don't know. I get confused with the 1 minus something.
Agreed. There's a lot going on there, definitely. So what should it be? And this is definitely 7. You're totally right there. Yeah, and I'm with you there, Allie. It's a lot to think through. It is. There's a lot going on. So what would it be then? 1 minus 2.
I get confused because I'm like, do I go 1, 0, -1?
Yeah, that's what you would do. That's exactly it. It would be -1. Because if you're thinking 1, okay, so here, you know, I'm gonna old school number line it just cause I can. So if we're here, oh, there's that. And if we're gonna go -2, That means we go 2 in the minus direction. 1, 2. Bam. -1. Okay, so that's J prime. So then using J prime, translate the rule, using the rule, 2 units to the right and 1 unit down. So we want to go 2 to the right, so that's going to be +2 and 1 unit down. So -1, 1 unit down. So then what would J double prime be? So this is moved again. So we first did the first translation, we subtracted 2 and then added 4 to the y. So we got here. Now we're going to do another translation. We're going to, from this one, add 2 to that x and then subtract 1 from that y. Where would I be? What do you guys think? You can raise your hand or type it. 1, 6. Yeah, very, very good. So if I would add 2, ooh, I like the yellow on here. Add 2 to that x, that puts you at 1. And then subtract 1 from that y, that puts you at 6. Good. So J double prime is 6. Now here's the question. What could our rule be to get from J to J double prime? What could our rule be? Flames? Flames on the side of my face. No. Just kidding. What do you guys think? Does it look like the y, the x ended up changing at all? The x kind of stayed the same, didn't it? Because we moved 2 to the left, and then we went 2 to the right. So we kind of canceled out that change. But what about the y's? How do you get from this y to this y? What did they do? Like operation-wise? They add, subtract, multiply, divide. What did they do? We're not multiplying. It's only adding or subtracting. Three to 6. How do you get from 3 to 6? You add 3. Yes, totally. We would add 3 to get. Would you stop that? What is wrong with you? Sorry, she just like smacked the kitten. Nope. Here, you need to sit.
No.
Then go sit down.
No.
Otherwise, no shells.
No.
Okay. She has shells she wants to paint. We add 3. Or you are totally right, Dallas. It's 3 up. So we would say, we could write this mapping. We could say x stays the same, but for that y, you add 3. Or you would say it's that translation of whatever x is, but then you add 3 to that y. Innocent little baby's cold. No. Or we go up 3. Up 3. Very good. Good stuff, guys. Okay. So now we got to talk about reflections. A reflection does not change the size or shape of an object, but it does change its location and orientation. It's that mirror image. Okay? So mirror image is that reflection. You guys know what a reflection is. You look in the mirror and it's kind of reversed back at you. So I want you guys to pick with your colors there all of the reflections. What are the reflections? And remember, it does not change the size or the shape. Did you say straight up no? Don't say no. Yeah, you guys circle all the reflections. Yeah, good. Good, good. There's one more. Una más. Yeah, that one's a reflection. It's a reflection through the origin. It's really weird. Yeah, reflections are that mirror image. Good stuff. Okay, so this is what actually happens on the coordinate grid when you do a reflection. This is a chart you want to write down. Okay, so if we have a reflection over the x-axis, the x coordinate does not change. So here's our grid. If we have, let's say we have the point, I don't know, 2, 2. And if we're going to flip it over the x-axis, what happens is the x does not change, but the y does. The y goes negative. That's a reflection over the x-axis. If we reflect over the y-axis, so if we go here, here's our point 2, 2. The y doesn't change. If we flip it over the y-axis, the x goes negative. So that's a flip over the y-axis. There's also two other flips they could do. They could flip it over this line y equals x. This is like a, Lizzie, turn that, can you go sit over there, honey? That's distracting. Oh my gosh. She's a booger butt with her deodorant feet today. Oh goodness, stop that. Okay, so this is the line y equals x. So sometimes they will also have you reflect points over this line. So let's say we had like 1, 4. So if they have us reflect over this y equals x line, what happens is the x and the y's actually flip. They flip spaces. So if I reflect it, I won't have 1, 4 anymore. I'll have 4, 1. And I just sketched it out so it doesn't look like a reflection, but that's what actually happens is they switch places. And then if they have us reflect it over the origin, so if you go from quadrant 1 like to quadrant 3, then both your x and your y go negative. So instead of 2, 2, you would be left with -2, -2. And that's how I think these through. I always have to kind of be like, okay, what are they saying? What am I doing? But that is what we're doing here. We're just kind of switching coordinates. And it's super confusing if you don't have a resource. So this is definitely something that you want to have just to refer back to. Or even if you refer back to the Moodle page, it's all on the Moodle page. Okay. Do you guys questions? I'm assuming we're writing stuff. Can you do a hand raise once you're done writing this down, please? Just get some sort of it down, screenshot, whatever. If you have the dual monitors, you could screenshot it, have it up on one page while you're doing your homework. Yeah. I have a snuggly kid napping on my lap. She's so cute. How you guys doing? Stella, you got it? We're almost done. Almost done. I know, translations are crazy. Dallas, Allie, Tyler, how you doing? Got it? Okay. I'm not hearing anything. Stella's saying yes, so beautiful. I'm gonna clear it. Oh, if you missed it, it's okay. I'll put it on Moodle. It's all good. Okay. So if I want to reflect this over the x-axis, okay, good, good, good. These have the same points. I'm not going to do every one just for time, but what I actually am doing is like we would list D. D is at the point 4. -4, and we just got to think about what we're doing. Okay, we want to reflect it over the x-axis. This is the x-axis, so we're going to flip it up here. So x is going to stay the same, but y is going to change because this is where the y's are positive. So what would my d prime be? What would d prime be? Not -4, because in this one, this is where y is staying the same and x goes negative. -4 is over here, and I'm actually really glad you did that. That would be a flip over the y. So you just flipped it over the y. Yeah, we would have 4, because remember, 4 keeps it in the same area and just puts it right up here. It flips it over the x-axis. Okay, let's do one more real quick. What about C? If C is at 2, -6, what would C prime be if I want to flip it over the x-axis up there? What would C prime be? Oh, yes, innocent little baby. What can I do for you?
So, are we ever gonna like encounter problems that involve flipping or what's it called?
Reflecting.
Reflecting over like something that's not the x-axis or y-axis or origin? Like, are we gonna have to ever deal with that?
Good question. Not here. Not in this situation. No.
Okay.
No, they would. These are primarily coordinate plane reflections. And if they had you reflect over like a specific line, which they won't, you would just, remember, we're just counting kind of how far we are away. So if I want to flip this over the x-axis, I would look and say, whatever I'm reflecting over, I am 4 spaces away from that. So if I want to flip it over, I have to be 4 spaces away on the other side as well. So that, yeah, and the C prime would be at 2, 6. Yeah, because it was at 2, -6, and that 6 turns positive. Yeah, good job, guys. Oh, it's okay. The other one was at -4, -4, so I get that. Cool, so we're turning the y1 positive, and I would just follow this chart. That really helps. Or just think about where you're flipping it to. And I don't think we really, lines of symmetry, I don't know if that'll come up, but lines of symmetry are lines that can be drawn through some geometry figures. It's all on the Moodle page if you need it, but I don't think you do. I think it's, comes up a little, I don't know. I don't think we need it yet. But that is actually all I have for you lovely people today. If you encounter a question that you're like, whoa, this doesn't make sense, just send me and ask my instructor. I am at my computer. If I go to the hospital, I will have my computer with me. But I usually don't stay that long because it's weird there. But thank you guys. You have a lovely day. You are free to go. Thank you for coming.